Hello and welcome back to NorCal 715. Today I have an instrument cluster. This one's out of an '02 Silverado half-ton 4x4. It's got the big 5.3 in it. And the customer pulled this out and called me. Who just wanted to know if I could take a peek at it and see if I might figure out what's going on. He says his Prndl display is dim. And so I want to take a look because I know there is a common problem with these things. Anytime there's a vacuum fluorescent display, just a couple things you got to look at. I suspect the heater or the filament voltage is low, which will cause a dim display. And so now on this unit, it's got a circuit board on the back of it here, and I've already unplugged the circuit board. You don't have to move the needle pointers. It's already unplugged, so I'll just lift it up and out of the way. The stepper motors actually plug into sockets on these, so you can just pull the circuit board off. Now I've already unsoldered the odometer and the Prndl display from the circuit board just by unsoldering these connections right here. And I'll show you the back of the circuit board where that goes. It's right there. So that's already unsoldered and ready to go. So I'm just going to go ahead and set this part completely out of the way. Here's what I found preliminary right off the bat is there's three 100 ohm resistors and they're all in parallel as you see here, which means I should theoretically be able to read 33 ohms when I read across these resistors. And they actually go to these last pins, and always on a vacuum fluorescent display, the end pins are the filament or the heater voltage. So if I go from this first pin over here, which should connect, it connects to that 0.3 ohms, and then if I measure from this pin over here to the pad, I should get another 0.3 ohms, that's good. But here's what's interesting, if I measure from this pin to the heater, I should get 33 ohms and I read 50 ohms. And so that's telling me that one of these three resistors is not connected to the circuit board any longer. And so if I go to these pins, I should be able to read 50, 50, 33. I've made connection now. So that's going to tell me it's 50 ohms again. I just need to go ahead and resolder the ends. There it is, 50 again. 50. 50. 33. So I think it's going to be this connection right here. So what I'm going to need to do is just add some flux and add some fresh solder to these guys and just go ahead and resolder it. And I think that's going to take care of it. We could pull the resistors out and I could clean the leads, but that would involve completely unsoldering all of these connectors to the vacuum fluorescent display. And I really don't want to have to do that. So let's just see if we can get these resistors to take a little bit of solder, and then we'll measure it again and see if we see any kind of a difference. So I'm going to be using the Amtech flux. Here is the part number. Of course it says it has expired already, but I found this stuff to be good years and years after the expiration date, so we're going to go ahead and use that anyhow. So I'm just going to go ahead and add a little bit of flux. It actually makes the solder stick a little bit better. So we'll flux up all three of those, and we'll flux up all three of those. Then when we hit them with the soldering iron, it should actually cause the solder to become molten much, much easier. So I've got my 851D plus warmed up to, I'm going to take it up to about 900 degrees to do this. I'm not really worried about damaging the circuit board. I'm going to use the Kester 6040 solder. It's a really good solder, 31 thousandths in diameter. It's rosin core. I've got some 6337, I believe, but this is only 15 thousandths diameter. Very, very thin solder for doing surface mount work, but I think I'm just going to go ahead and stick with the 6040 31 thousandths diameter. So let's just go ahead and we'll give it some heat here. Oh, it's a perfect looking solder joint now. Wow, that's really working excellent. Now that one's having some trouble taking the solder. This one over here just does not want to take the solder. We'll keep working at it, maybe do a little bit of scraping on the circuit board. The resistor lead is taking the solder, but the board itself is not. There it goes. So let's just hit it with a bit more flux, because I want that one to look like the other ones once we're said and done. I'll hit all three of them a little bit. We'll wipe off that flux a little bit later. Alright, that looks really good. So next I'm just going to go ahead and I want to hit the filament leads just to make sure we get a good connection on those guys. May have to add a little bit of flux to those. They have a very small conformal coating, but normally the heat of the soldering iron will get right through that with no problem. There we go. And then we'll just hit these end connectors here as well. So that one end connector is the one that supplies power to this end, and then over here and it goes to the opposite end. And I'm just going to add some flux over here. And we'll just try to hit those one more time. We'll just have to clean those off, a little bit of acetone. And just for the heck of it, let's add some flux on those two as well. Alright, so next I'm going to take my favorite chemical to clean, well, about anything. Circuit boards, video heads, belts. And I'm going to go ahead and put some in my little dish right here. I'm just going to hold the circuit board in here and get my acid brush. And we'll just clean off all that flux. Clean off the terminals that I soldered. Now I'm not worried about hurting the vacuum fluorescent display on this because it's made of glass and it doesn't have any kind of like a polarizing filter on the front of it or anything. So here in just a second we'll go ahead and do some resistance measurements and see if we can get 33 ohms like we should have. There we go. Now I'm just going to let it naturally evaporate. You can see it's still on there. It'll take a minute or two and it'll dry off and it'll be just like new. Alright, so let's take a look at the connections. So I did solder these two right here. These actual three resistors, 2 connections each. And then I went ahead and touched up the filament or the heater leads on the input connector right there, as well as these two up here. They look absolutely perfect. So here's what the front of the vacuum fluorescent display looks like. There's a little part number over there on the side. So let's get the voltmeter out and measure ohms of these resistors and see if we get 33 ohms like we should have now. Alright, we're on ohms. I'm just going to go ahead and short the leads out here. So just for the heck of it, let's measure and see what the resistance is of the filament, 2.5 ohms. So let's measure the resistance from the first terminal to this side, and I won't use the resistor lead, I'll use this pad right here, 0.3 ohms. Then we'll measure from the return of the filament to the other side, and I don't see a pad to measure at, so we'll just take one of the resistor leads, and we see 0.3 ohms there. And now for the all-important test, we'll measure from the filament lead to the input pin over here, and we should see 33 ohms, and we do, 33.3. Much better than 49 or 50 ohms before, because we only had 2 resistors actually doing the work. Now we have 3. And so it's going to be feeding the voltage into the filament, which measures 2.5 ohms DC resistance. Now, I'm not going to actually apply power here, so we should see about 33 plus 2.5, so 35.5 ohms. It looks absolutely perfect. So next I'm just going to go ahead and reassemble this, and I'm going to go ahead and give it back to my customer. All he brought me was the cluster. He didn't bring me anything else. No truck, no anything, and he pulled it out himself, just with the fact that I would just go over it and do a visual and electrical inspection. And I think I definitely am going to get to the bottom of this, because if the filament voltage is low, then the display is going to be dim. So let's go ahead and reassemble this now. So I thought really quickly I'd just do a quick look-see on the board and see if I see any other problems whatsoever. So far I haven't seen anything. One small issue piqued my curiosity, and it's this one resistor right here. It's a 100 ohm resistor, it looks like. And so let me flip the board over so you can take a look at the bottom of it. It's been running just a little bit warm. You can see it kind of heated up the connection right there. So it looks like that one resistor is probably the supply for these 3 other resistors right here. So I think I'm going to do the same thing. We'll give it a quick touch-up solder job just to make sure it's got a good connection. So we'll give the resistor just a little bit of flux on each end. That should be good. Once again, I'm in the high 800s, almost to 900 degrees, to make sure I get a good melt of the solder, good wetting effect. Wow, that looks really good. Took solder great. So let's go ahead and clean it off now. So there's all the flux off. But those connections look absolutely perfect right now. So let's go ahead and I'll just put the meter next to it here. Hopefully you can see everything on the screen as it's zoomed in here. And we'll just do an ohm check of that resistor. It should read about 100 ohms. 100.6, so that's very good. So I'm going to go ahead and reattach the connector. Just have to put my pins through and solder it right here. So let's go ahead and do that now. Alright, so we'll go ahead and put the header back through the pins. Just got to get, there we go, get the little plastic tabs into place here. And it should snap right back into place like that. Now we'll go ahead and solder it up. Go ahead and clean off the flux. Now my customer indicated that he had replaced some of the incandescent bulbs here in the past because they burned out, and he didn't seem interested in doing any kind of an LED upgrade. He didn't mention that, because I could certainly, this would be the time to replace these incandescents with LED bulbs. But anyhow, let's go ahead and put it all back together at this point. Everything looks good. Solder connections are great. So real quick, if you're unsure about doing this repair with these connectors right here and having to solder and unsolder, I've seen guys bend them up out of the way, but I'm worried that might fracture the solder joints on the circuit board. So if you have your ohm meter, just put it in the ohm scale right here. Even on auto range, it's okay. And just go ahead and measure from the circuit board the top and the bottom pins. and see if you get 35-ish ohms. So if you had a resistor open or a connection open, then you would expect to see about 52 ohms. 2 open would be 102 ohms, and all 3 open would be infinite. So if you see 35 ohms, then I'd say that's not going to be your problem. However, it's probably not a bad idea just to go ahead and take a look at the connections, because a lot of times they are very temperature dependent. As it heats up and cools down, they will expand and contract. So next I'm just going to go ahead and snap the front back onto it. Everything should just line up quite easily. I just don't want to do any damage to the reset button right here. So once I've got these lined up with the stepper motors, I can just do a gentle press all the way around. Once you've got them on, you can actually see the end of the pin press through the circuit board. There it is, all mounted back together. Well, I'm going to give this back to my customer and let him go ahead and make the final decision as to whether this made a difference or not. So I just did this real quick chart to figure out the voltages. So if we have 33 ohms, as in everything is correct, with 13 volts supplied, we should have 2.5 ohms on the filament and 0.910 volts across the filament and 12.01 across the 33 ohms. But now if we break that down and it's only 50 ohms with only 2 resistors, then we should only have 0.619 volts across the filament, 12.38 across the 50 ohms. And then if we go one farther and we only have one good working resistor, we should have 0.317 volts across the filament and 100 ohms with the one good working resistor. And so if the filament is a non-linear curve like this, at 0.3 we can see it's a very low voltage here. At 0.6 it's a little bit higher, but at 0.9 it's way up here, so the brightness should theoretically be much higher. I hope that helps. Alright, so here's the after. I got the customer has his cluster semi-reinstalled in here, and as you can see right there, it's got a pretty nice bright display at this point, and he's turned the headlights on and off, making it brighter and dimmer by a little bit. Hard to see on the phone, but man, it looks great. It looks like the day it rolled out of the assembly line. Anyhow, just wanted to give you a quick update that it looks good. So if you're having a problem with your GM cluster, take a look at those resistors that are on the vacuum fluorescent display, and resolder as necessary. Make sure you use good flux so the solder flows well. Anyhow, that's it. Up and running.